Good morning, students. So last class we have seen about the sums of the arithmetic sequence. So we have seen many formulas also. So first formula, it was if a arithmetic sequence is a natural number, we can use n into n plus 1 by 2. That is for the sum. If a arithmetic sequence is a first even numbers, that is starting with a 2, then we can use this for the sum n into n plus 1. If the arithmetic sequence is odd numbers, that is starting odd numbers, then we can use n square. So these are the three categories we have seen, and also the final one, the important formula we have studied, that is finding sum of the any of the arithmetic sequence, that is n by 2 into x1 plus xn, or n by 2 into the first term plus the last term. That was the formula we have studied, and we have done many problems also. Now we are going to see one of the problem, page number 35. We'll continue the problem now. The question number 4, page number 35, question number 4. What was it? Find the sum of all 3-digit numbers which are multiples of 9. Which means find the sum of all 3-digit numbers. All 3-digit numbers. And also condition given which should be multiples of 9. So before choosing that, you want to see which all those 3-digit numbers. Starting 3-digit number, which one? 100. 100 is the starting 3-digit number. So, etc. What will be the ending 3-digit number? 999. So, these are the 3-digit numbers. In between, there are many 3-digit numbers. But all those we can't take because condition given, all the numbers should be multiples of 9. Whether 100 is a multiples of 9? No, it is not a multiples of 9. So, like that, we want to see the numbers which should be the multiples of 9. So how can I find that? So for that, one easy method I can make. 100's previous number, which one? It is a 99. So just I'll check out here. 99, it is a multiples of 9. So what will be the next number which will be the multiples of 9? That is, multiples of 9 means everywhere adding 9. 9's multiplication table, no? 9 are adding everywhere. So 99 plus 9, what will be the answer? 99 plus 9, it is 18, 1 carries, 9 plus 1, 100, 10. So 110 is the answer, which means 99 is the multiples of 9 and the next number will be 108, that is which is the multiples of 9. So this is the starting number which will be the multiples of 9 in 3-digit number. So 100 I cannot take because it is not a multiples of 9. So starting number I got 108. 108 is a multiples of 9. Keep in mind. So that is the starting number. So etc. Now the ending 3-digit number 999. Whether it is a multiple, it is sure. It is multiples of 9. Or if you divide, you will get remainder 0. So that only I can take it as a ending number. So which is the first number 108 and which is the last number 999. Now what is the question actually? You have to find out the sum of all these 3-digit number which are multiples of 9. Only the multiples of 9. What is the formula for sum? Sum is equal to, you have studied that n by 2 into x1 plus xn. x1 means the first term, xn means the last term. So that is there, x1 is there, xn is there, but n is there. N means what? Number of terms. Number of terms means between 108 and 999, how many terms are there? Whether you know how many terms are there? We don't know. We cannot count by writing each and everything. That is difficult because it is too large it is. So n we don't know, number of terms we don't know. So for that we have to find out that. That is, previously we have studied one formula, that is checking number. You all remember that if a number is given, we are checking whether it is a term of that sequence or not. So that we have done the formula check number minus the first number by the common difference. That is, if it is divisible, it is a term. If it is not divisible, it is not a term. So that formula only using, but little slightly changes here. So now I can write it side. Number of terms is equal to, this is important, okay? Means whichever sequence is given, if we don't know what is the number of terms in between, we have to use this. Number of terms is equal. So number of terms is equal to last term minus the first term by the difference, means common difference, plus 1. So this is the formula for finding the number of terms. In a sequence, how many number of terms we want to find out? This is the one. Last term minus first term by difference plus 1. Plus 1 last you have to add. Now what is your last number here? 999 minus what is the first term? 108 by common difference. Common difference means here what they mentioned in the question, it should be multiples of 9. Multiples of 9, 9 only, no adding. So that is itself is a common difference. So by 9, put plus 1. Addition you have to do at last, okay. So 999 minus 108, how much it is? 9 minus 8 is 1. 9 minus 0 is 9. 9 minus 1 is 8. Divide by 9 plus 1. So this you have to divide first, then only addition you have to do. So we'll see what will be the division terms we are getting. 891 by 9. So 8 cannot divide, so you have to take a 2 digit here. So 89. 9 how much are? 9 nines are 81. So 9 minus 1 8. Again 1 reminder. 1 down. So 9 nines are 81. So it is divisible, no? It is divisible because reminder 0 getting. So what is the answer here? It is 99. So when you divide, you are getting 99 and this addition plus 1. So you will get 99 plus 1, it is 100. So that means how many terms are there in between 108 and 999? It is 100 terms, including 108. 108, next going on adding 9 everywhere till you will get 999. So there are 100 terms from first to last you have. So that 100 will be your n. So that you have to keep in mind. Now I am going to substitute here. N is 100 by 2 into x1 108 plus xn 999, means first term plus last term. Now this is the even number, you can divisible, it is divisible. 100 by 2 it is 50. Half of 100 is 50. Now you have to add this. How much you will get? Here 8 plus 9, 17. 1 carries. So 9 plus 1, 10. Here 0. 1 carries. 10 plus 1, 11. So 1107 you will get. So 1107 into 50. So that you have to multiply. So we will see here multiplication. 1107 into 50. For 0 I am putting later. So 5 I will do. 0 at last you can put 7 5s are 35. 3 carries 0, 3, 5, 5. So what is that? 5,535 and one more 0. We did not put that one. So it is 5,350 you will get. So this is the, what is that? Sum of the 3-digit numbers which are multiples of 9. All those clear, no? Multiples of 9, which all the terms we have to see, which all those comes under that, and you have to see how many terms are there in between. That is why we are finding, because n is there here, number of terms. We don't know what will be the number of terms in between. So for that, we have to use this formula. Number of terms is equal to last minus first by difference plus 1. So this way you have to do, you will get the n. You have to substitute the n here, then first term plus last term. At last you will get this answer. So the next problem, page number 35, the question number 6. There also we are saying calculate the sum of the following arithmetic sequences. Means the first sub question given 51 plus 52 plus 53 plus etc. plus 70. So these all numbers sum you have to find out. Means 51 till 70. And also you know what is the common difference? There is only one. One is adding everywhere. Now this sum you have to find out. What is the sum or formula? Sum is equal to n by 2 into x1 plus xn. So here whether x1 is there, first term is there, xn last term is there, whether n is there, n means number of terms. 51 to 70, how much you have to count? If it is small number you can count it right, that is the n. Otherwise if it is a larger and all, just now we did know how it is n we found. N now we are finding, that is number of terms is equal to last minus first divide by common difference plus 1. This is the way. So number of terms, which one you have to use? This is the formula. So what is the last term? 70 minus first term 51 by common difference. Common difference is what? Only 1. 1 is adding everywhere. Put this plus 1. Now 70 minus 51, it is 10 minus 1 is 9. 9, then 6 minus 5 is 1. So it is 19 divided by 1 plus 1. So 19 divides 1 means it is already 19 plus 1 is 20. So what is the number of terms you are getting? 51 to 70, there are 20 terms. So that is actually here n. So 20 by 2 into x1 is 51, first term, plus the last term 70. So like this you will get. Now 20 by 2 how much? 10. Half of 20, 10. Into 70 plus 51, that is 121. 7 plus 5, 12. So 121, 10s are 121, 1s are 121, 10. This is the answer. 1210 is the sum of this problem.